All right, guys, want to do a slightly easier video here talking about division with polynomials. And so what I've chosen to do first is to give you a little bit of an understanding of when we even need to consider using division at all. Because what we want to remember is that factoring is a very similar process to this division process, except factoring is usually easier to accomplish on problems that we've already been dealing with in math class, which is problems that are polynomials that are specifically of this quadratic category. So when we look at this graph here, we can see the zeros, and when we look at the equations, we can see that those zeros, so this factor here corresponds with this zero here. And when we recognize this aspect of quadratics, we are going to take that same concept and apply it to cubics and quartics and quintics and higher degree polynomials. So what we're traditionally going to be looking at when we do this type of work is a polynomial in standard form, which is going to look like this. It's going to have its lead exponent. The highest exponent is going to come first, and it's going to go in descending order from there down to the constant term. And sometimes in these situations, one of these terms is going to be missing, but the example that we look at right now is not going to have that scenario. So the only thing you want to make sure you know is that if it is missing, you should usually write it in as, if the x term was missing here, when you're doing a division problem, you might want to say plus 0x, just so you don't make mistakes. That's usually what that's for. All right. So what we're going to do is we're going to bump this up, because what we should already know how to do in this situation is factor this quadratic. We should know how to start with a standard form and break it down into this factored form. But what we don't necessarily have a strategy for is if I include an extra factor here, right? If I bump this equation up from being a quadratic equation to now being a cubic equation. So we can see that the difference is this cubic graph crosses an extra time because its highest degree exponent would now be a 3. And remember, that fundamental theorem of algebra tells us whatever that biggest exponent is the potential amount of times that we will see it cross the x-axis. But in reality, it's just the number of total complex roots. So remember, sometimes these graphs will not cross the x-axis that many times because some of those roots are complex, or some of those roots are potentially having a multiplicity higher than 1. So when we look at this example here, what we need to understand is that we actually need to take this entire polynomial here and multiply it all. So we need to take all three of these terms, make these two graphs match, and multiply this entire thing again by x minus 2, the missing factor. All right, so you wouldn't want to have dropped these parentheses earlier. That's not the same thing. And you can see that reflects in the graph. This blue graph does not correspond with the red graph anymore. So you want to make sure you're being really careful here. It's one of the nice things about Desmos is that it lets you play around with these ideas and see your own mistakes. So we can see that these two graphs match. And what we can see is that x minus 2 is a factor, which gives it this root here of x equals 2. And what we're going to do is we're going to take this entire equation. We're going to actually do this multiplication here, giving us the entire standard form. So all this is when we deal with this is just distribution. You're just going to take this first term and distribute it to all three terms inside here, which would give us an x cubed term, x times negative 2x minus 2x squared minus 3x. And then you move on to the next term there. You go, okay, well, I'm going to do negative 2 times each of these now, giving us minus 2x squared plus 4x plus 6. All right. So what we're looking at in total here for this blue graph that we see is x cubed minus 4x squared minus 3x plus 4x is plus 1x, so just plus x. And then the constant term always ends up being the constant times the constant there. Those two always create this last part. which especially when you look at multiple choice problems, if you're asked to figure out what all of this stuff multiplied together is, the easiest way to determine from multiple choice varieties is just to take all of the constant terms and multiply them. So 1 times -3 is -3, times -2 is +6. If you're looking at multiple choice options and you don't see a +6, then that's not the answer. Instead of dealing with all these terms that end up combining in the middle, you can just weed out the answers that don't have a +6 at the end, right? Pretty quick, easy way to narrow it down some. All right, so besides the point, what we want to see is that this is the standard form, and we want to divide out, we want to cancel out one of these particular factors. It doesn't really matter which one we choose, but the way that we would tell which things do divide in is by looking at the graph, right? We're not expected to be able to look at this cubic and know what the factors are. So instead, what we would do if we could is look at the graph and choose one to divide out, or more frequently, the problem will just tell you what to divide into the polynomial. And when they just tell you what to divide in, they are asking to see whether or not you understand, one, the process for division, and two, whether or not that process tells you that the thing you divided in is indeed a factor. And all you need to know about division as a process in terms of whether it's a factor or not is it is a factor if the remainder is 0. It's not a factor if the remainder is not 0. Do a quick example for yourself with just numbers. Take the number 13 and divide it by 2. You'll see that there's a remainder here. It goes in 6 times, and 6 times 2 is 12. And when you subtract, you have a leftover, right? There's a remainder of 1, meaning, like we should already know, 2 does not go into 13, right? So it's basically the same thing with polynomials. All right, so let's get this written out on the graph and then actually do our division. So we're just going to type this in, x cubed in standard form, biggest exponent first, and then going down in descending order with the exponents, plus x plus 6. And let's clear off everything. All right, so we know we did this correctly because we can see that the graphs are exactly the same. And now it comes time to do the division. So what I'm going to do is I'm going to choose this new factor here to divide out. And what I'm going to want to see from that division is that this ends up being my answer. If I take this entire polynomial here in completely factored form and I divide by x minus 2 factor, it should cancel out, leaving me with only these other two factors multiplied together, which is this quadratic equation. Okay, so as a process, there's two ways to accomplish division. You can either use synthetic division or you can use long division. So long division looks like this. You're going to write out this entire cubic inside of the division bar, and the factor that you want to divide by here, x minus 2, on the outside. And remember, you're always going to try to take the biggest term and divide it into the biggest term here. You're always going to do that. So in this problem, you're going to take the biggest term that's on the inside, x cubed, and you're going to divide it by the biggest term that's on the outside, x. And whatever that ends up giving you is what is supposed to be the answer in the top. It's really that simple to figure out the answer. The biggest term here divided by the biggest term out here, and it's a done deal. So that ends up giving you x squared. Now, the only thing you need to understand about this process is that when you figure out that it's supposed to be x squared, is that you're then taking what that is, right? Just like the division process with numbers, you're taking what this quotient is, what this answer is, and you are going to multiply it by what you're dividing by, which here distributes in, and that is what you write below your problem here to subtract out. So it ends up giving you x cubed minus 2x squared. So we write that down here. That's where this comes from every time. And then when you do the subtraction part, remember that you change the signs on both of these values here because you're going to subtract two terms from two terms. So you're not just adding these two and subtracting these two to cancel them out. You're subtracting here and subtracting here, right, in each little column. So you change the sign there, change the sign here. And now you go straight down. These two should always cancel out because that's what this division ensures happens. When you do that division and you multiply by this value right here, that ensures that those first two terms will cancel out, all right, if they can. So here they do, they're gone. And now here you change this middle sign. So now you're doing negative 4x squared plus 2x squared, which is going to be negative 2x squared. And then you're going to drop down that next term, just like you always would in division. So plus x. And now when we do this division here, we're again going to take the biggest term of what's down here in our problem, divided by the biggest term of what we're dividing in by. So we're going to take negative 2x squared and divide it by x, and it's going to end up giving us negative 2x. We're going to take that negative 2x and we're going to distribute it into x minus 2. And we're also going to take that negative 2x and write it up here in our answer. Should have done that first. All right, so that comes from this solution here, right? Before we have all this distribution happening, we're going to take that answer that we got from this division and write it up above that term in the solution, in the quotient. And then we distribute it in to x minus 2, which gives us negative 2x squared plus 4x, negative 2x squared plus 4x. And then we're going to go and we're going to subtract. So we're going to change the signs here, change the sign here to minus. So we can erase out that plus there and make that a minus now. And then we're going to go straight down in both columns. So these two, again, cancel out by design. And then you have x minus 4x will be negative 3x. Drop down the last term there, plus 6. Last step of division is going to be to take biggest term divided by biggest term. So negative 3x divided by x equals negative 3. You're going to write that negative 3 up here in the answer, and notice here, boom, how this matches the quadratic that we had up here in this factored form, which means it's telling me those other two roots from the polynomial. I divided out this x minus 2, 1. I can see that I ended up getting a quadratic back, and that it is indeed the same one that built this original equation. Okay? So I distribute in, and to tell that everything worked out correct, when I distribute this in here, everything ends up matching. It equals negative 3x plus 6. So I see that this matches here. And when I go to change the signs and subtract, I'll know that everything cancels out. So that's a minus now, right here, which ends up giving me 0 as an answer down at the bottom, which meant, again, that x minus 2 was a factor. Right, I had a remainder of 0.